Question number 20. The spring has a spring constant K. Okay, spring constant K. The spring obeys Hooke's law and experiences extension X. Okay, so there's initially one spring with a spring constant K, and when you applied a force F, it produces an extension X over here. So this was your force F, and it produces an extension over here. Okay, and then elastic potential energy of the spring is EP. So I will write F is equal to Kx, and your EP was given by half Kx square. The diagram shows two of these strings joined together in parallel and hanging from a fixed beam. I have put two springs over here. Whenever you put two springs in parallel, the effective spring constant will be equal to 2 times K. Why 2 times K? I just added K plus K over here. Okay. If you want a tutorial on this, I can make it out. Just put your comment on your comment section. So definitely I will do one tutorial on how do you get this one here. So at the same context, when you say when two springs are added in series like this, what is your effective spring constant? Effective spring constant will be 1 by K1 plus 1 by K2. This reminds you of doing the problems in electricity. In electricity, what was parallel? In springs, it is series, ulta. Okay. And what is series in electricity? It is going to be parallel in springs. Okay. So you are using the formula analogously. Okay, effective equal to 2K. Now, what is the extension total elastic potential energy of the arrangement? The same force F is applied. When you apply a force of F over here, what are the values of F and EP? That's the question. So, very easy question. So, what you can do is you want extension. Here, what is the extension? In this case, X is equal to F by K. Okay. Now, in this case, what happens? You will have the same force F. I am writing F here. This should be equal to 2K. And extension I do not know, I put X dash over here, which means X dash should be equal to F by 2K. Now what is F by K? F by K is X. Now this should be equal to X by 2, right? F by K into half, which should be equal to X by 2. I just took it from here. X equal to F by K, right? I substituted here. So X by 2. Now half of the extension, these two goes away. These two goes away, one of them should be correct. Now don't just directly jump into saying energy gets hard. Just do it and then infer it. Now, what is energy? Elastic potential energy is given by half Kx square, right? For the new one, this is your EP dash, is your K dash, is your X dash square. So, this should now be equal to half into 2K into X dash. What is X dash? X square divided by 4, right? I just substitute this value here. So, this should now be 2 1s are 2 2s are over here. I will once again write this as half into half Kx square, right? Kx square by 2 I have, this half I will retain outside. Now half Kx square is nothing but EP, so this becomes EP divided by 2. Okay, so EP divided by 2, answer is here.